Good morning, everyone. This is obviously a video lecture that I recorded a couple of days ago. I'm in Quebec, and as you can see, the sun is blasting in. I can't really see so good, so I'm probably gonna turn off the camera for quite a bit of this and just chat. But today, we're gonna be thinking about feedback and recursive systems, the beginnings of that. We've done a lot of stuff so far where we've looked at things where we're basically working with these XY coordinates and making things move in space. And this is going to be slightly different. We're going to start thinking about how pixel math can do interesting things. It gets us into these realms of sort of image processing, but also we can start simulating things like some hacky reaction diffusion. We can also think about ideas like the game of life, which look at pixels and things like that. So we can start creating these types of simulations that work a little bit differently to what we've been doing so far with the generative art, and it's going to be really exciting. This week I'm going to give an introduction to a bunch of artists who are working with sort of recursive systems, and particularly video feedback. We're going to look at that, and we're going to look at how you can build video feedback in processing. That's going to be part of our lab later in the week. We're also going to look at a new piece of software, which I'll do a sort of a walkthrough, called Touch Designer. And Touch Designer is I know some of you folks have used Macs. I know you don't all like it, but Touch Designer is, it's actually a pretty cool tool. It allows us to do a lot of stuff that we can do in processing, but without code. So it's really quick, iterative prototyping. Differently to Macs, it is built on Python. Macs is built on C. I did show a couple of students that there's some ways of actually programming in C in Macs, and also there's a plugin where you can code in Java. But Touch Designer is going to be, it has its own proprietary language, but primarily when we do scripting for it, we're going to use Python. We're not going to get too deep into Python. Some of you might have used Python before, some of you might not. We're going to be using a lot of the same types of functionality that we've already looked at. So sine, cosine, we're going to be getting the timestamp from Touch Designer's own program. But Touch Designer we're not going to be using it as the full development tool now, but it's a good thing to learn. It's really useful. I use it a ton for installations because, one, it's really quick to iterate and add in user interactivity and just change on the fly, versus processing where you've seen where we do some changes in the code, we then have to stop the draw loop from running and we have to start it up again. And it's not quite so interactive as with something like Touch Designer, where you can be running something and you can just start plugging in a bunch of new functionality while you're performing. Touch Designer also is really good at just working well on the GPU. All the video stuff that it does is really, really efficient. And we've looked a little bit about optimization in our processing code, but when we work with Touch Designer, we don't have to think quite so much about optimization, because it kind of does that. As obviously anytime you're building a system, there's going to be optimization things you can do, but Touch Designer automatically has a lot of things built in that help with optimization. So quite often you can run quite intensive simulations or pixel operations at a really high frame rate, which is awesome. So Touch Design is a pretty cool tool. I'm excited to show it to you. And because this week we're looking at a whole load of new stuff, we're not going to have an assignment on this. We're not going to have a sketch. Remember how last week the homework, instead of being a 1-week project, is going to be a couple weeks. We're going to do that over reading week and can submit that when we get back after reading week, the last assignment, which sort of sums everything up that we've done in the first 4 weeks of our generative art, physics, p-vectors course. So we're moving on to some new material now, and this week we'll just be focusing on learning about video feedback and recursive systems, doing a little bit of that in processing. I'll show you some examples, and also looking at how to just use Touch Designer to make a basic reaction diffusion system. So what are feedback and recursion? I'm going to start off with an example that maybe you've encountered. I don't know if any of you have ever experienced this on Zoom, but sometimes if you are using perhaps an external camera and you pointed that camera at the screen where there is also an image of you, you might have seen an image like this. And this image is video feedback. And this results when the camera is pointed at the screen, the camera sees the screen, and so there becomes this feedback loop between camera and screen, where the screen is feeding into the camera and the camera is feeding into the screen. And because of the time that information takes to travel and light takes to travel and processing, there's a lag, and there's interesting things that happen in this lag. So we can see here, because of this recursion, because of this feedback, we have a trail going backwards. And if the camera was to be moved, we would see that offset slowly and move around. And we'll look at some examples of that later, because it's a relatively easy effect to recreate manually. We can take a camera, plug it into a computer, open some video software, and we can make the feedback happen just by pointing the camera at the computer and seeing the screen. So just taking my phone, plugging it into the screen, feeding it back. Not very high tech. I could do better with the lighting. And one thing we can see is that it's additive, right? So if I have the brightness, even midway, it's going to very quickly become fully washed out, because every time we're adding to that set of images, like each recursion is adding some brightness in. So that's something to bear in mind, that when we work with feedback, there's always going to be this threshold point, whether it's working with feedback that is audio, because in audio we can get to this point of full feedback where it's completely white noise and it just sounds horrible. And the same with video, right? So if I'm giving too much brightness to that signal, we're just going to eventually get a fully white, washed out screen. But that's something to bear in mind, that this is an additive process, so it's quite easy to get things that end up strobing or just giving you only one color, and you lose your effect pretty quickly. It's kind of interesting, but we're going to look a bit more at the computational aspects of feedback. It's really useful in a whole load of things. In audio processing, it's useful because feedback is the basis of a lot of audio filters and things like delay and reverb. You can build those using elements of feedback. And it's also really useful in recursive programs. So some of the programs we might want to create that have these recursive elements. So this idea of recursion and feedback is something that we may have already used. If we go back to the first assignment with the grids, there was a little extra challenge if people were feeling really comfortable with that, where I suggested that you could create a subdivided grid by using a recursive function. And in this instance, a recursive function is a function that calls itself until a condition has been met. So we can see in this diagram here, recursion recurs. Very, very simple. But we see here it sort of goes on forever. When we computationally think about this idea of recursion, we need to set an exit condition, because we don't want that cycle to keep going forever. Otherwise, it's either going to not let us run the program, or it will let us run the program but will eventually eat all our memory or crash the computer. So that's not an ideal situation. So this is a really simple example of a recursive function. We can see here I have my void drawRect function, and I've given it an x, y, and an r parameter here. R is just going to be my size. And I call my drawRect function one time in the draw loop, which starts that recursive function. And then when it's called, it's going to draw a rectangle. I have an exit condition. So until my rectangle size is below 2, I'm going to -20 and call my function again, which is then going to repeat the process of drawing a rectangle, minusing 20, and checking to see if it's less than 2. So it's going to keep reducing the size of that circle by 20 pixels each time until it hits that central point that fits that exit condition. And I'm going to reiterate, it's really important to make sure we have an exit condition when we work with recursive functions, otherwise things can start getting quite messy. So a slightly more complex example of a recursive function allows me to subdivide a grid, and I'll just open up that code for you. And we can see a few similarities to that code we just looked at. We have a function that we've set up. We call it one time in our draw loop. And I've added in a few more calls internally to that function. So it's calling itself a couple of different times. And that's allowing me to have these horizontal and vertical subdivisions of the grid. So by augmenting that recursion, I'm making a more complex overall pattern by stacking that on top of itself. And I can run that and generate lots of different grid patterns just using that simple recursive algorithm. And I could also apply that to, say, cutting out chunks of an image and recombining them, taking from a certain position, and then just copying that chunk of the code. So rather than taking a single pixel, it's taking a chunk of the image and copying that into a square. Recursive functions are also really useful for generating fractals and things that have self-similarity that repeats over multiple scales. So this tree structure that we see in the image here is something that we could recreate fractally through using a recursive function. And by going back to a couple weeks previous, we can remember that example of the game Euphoria, which uses fractal style trees to create this unique generative artscape. Recursion is also an extremely useful tool for us for solving computational problems and calculating things such as factorials. In this example, I'm calculating the factorial of 6. And what we can see here is that a factorial, which is denoted by this exclamation mark after a number, so 4 exclamation mark says 4 factorial. And that basically means we're multiplying all whole numbers from our chosen number down to 1. So in this example, 4 times 3 times 2 times 1 equals 24. And let's open up that code and take a look. So we can see here we have our factorial function, which calls itself. So we can see here that in the return, we have n times factorial n minus 1, and that's what we're returning. And we do our initial call to factorial here, where we're giving it the value of f1, which in this case is 6, where we will give it a number to find the factorial of. So let's run that. And I've added in this section here where I'm printing the value of n on each recursive call. So we can see here that we have 6, 5, 4, 3, 2, 1. So it's doing what we're hoping it would do. It's taking away. And we also see the final result, which is all those numbers multiplied together to get the factorial. If I brought up the calculator, we could say we could put in that string of numbers and we would get the same result. We could also flip this around somewhat, and we could do something like, we could replace that multiplication with another, say, addition sign. And we can see here that we would get the additive value. So keeping in mind this idea of recursion, let's have a think about how we could apply that to the video feedback concepts we looked at earlier in the class. I'm linking here to a really great article on video feedback by a creative coder called Andre J. I'll link that in the slides. But we start off here in this article with this simple idea that we've already looked at, this idea that we have a camera and a screen. They're both very similar, and we're going to feed them back in some way. Here's a short video from Andre J on video feedback. A bit of a primer on video feedback, and we're getting the idea here that maybe people that like video feedback also like strange experimental sounds, and that's definitely a theme here. Anyway, this article has a lot of just really useful visual interpretations of these different effects. So we saw in that video how displacement can move things in an XY axis, it can shrink things, changing the brightness of something can cause an additive effect where things start to bloom and brighten. So we can see these simple diagrams that have been drawn out. And I'm not going to go through the whole article. I'll link to this so you can take a look at this in your own time. But we can see these simple examples which almost kind of remind us of these matrix rotations that we looked at in our first week of using processing. So we can think about those rotations when we start thinking about these elements of feedback. It gets more complex, so you can look at gradients and variables there, but also you can see how these types of effects have applications in fractal systems or game of life type systems. So this is a Wolfram system, so you can go in and experiment with some cellular automata. There's later also links to videos of more classic video feedback where people are just pointing a camera and experimenting without thinking too mathematically. And if we go all the way down, we can see some sinusoidal functions, some bifurcation diagrams, which we'll get into a little bit later. But yeah, this is what I wanted to show you. We have this link here. So we have code links to code that has been made in processing and open frameworks, two creative coding languages that we can use. We're really familiar with processing, so we can check out the processing code. And you can download that and experiment with applying video feedback in processing to some sinusoidal wave patterns. And let's take a look at making some video feedback of our own. So a really great tool for creating quick and easy video feedback is Touch Designer, which I mentioned earlier. And I'm not going to go too much into the operation of Touch Designer today. That's going to be something we look at more in our lab on Friday. But I'm going to show you in real time how we can create video feedback. And this is also something we can look at doing in processing, and everything we do in Touch Designer we'll also take a look at in processing. But by using two different tools, we can start to understand their pros and cons and start creating this framework of a modular toolkit for using different tools for different projects when it benefits the project. So as I mentioned earlier, like Touch Design is a really great tool for anything that's going to be real-time video effects and that's dealing with like pixel operations. Processing can be good for that too, but it takes a bit more time to set up. So for sort of a real-time interactive tutorial, this is kind of quite fun. I've already set up a simple node system, which I'll be experimenting with in creating video feedback. But basically I have only very few elements, and we can see here that the UI I talked about a few weeks ago in Touch Designer, it's a little bit weird, so we'll figure that out as we go along. It seems strange at first, but you do get into it. Basically, you have all these nodes similarly to Max MSP, and we can see that they're connected in various ways. We have these wired connections, these purple wires, which I'm moving between various objects. But then also we have this sort of line that's moving between my composite object and my feedback object. And in Touch Designer, composite is an object that allows me to combine two video sources together and blend them in certain ways. So if I go into that object, we can see all the different blend modes I have. And if you worked in the Max MSP course before, you probably will have encountered something called DATT2040 which would be a similar tool to this composite tool, which allowed you to take two video feeds or two incoming signals and mix them together in a certain way. But Touch Designer is way more powerful and way more exciting than Max, so it's going to be a lot more fun to play with than doing stuff with JIT.op. So the first thing that we can see here is I'm taking the end of my chain, this composite here, and I'm feeding that back into my feedback. And right now I've disabled a couple of things, so we're not seeing that feedback, but we can think about this like the television screen, right? So we have our camera here, and we have our screen here, so input and output. And then this feedback is going to allow us to make a delayed frame, which we offset in some way. So I'll remove this transform, because I'll show you the different operations in a second. So right now I've set the opacity of my feedback to 0, so we can't see anything. But if I start turning that up, we can see that I get these trails, right? So we've created this one frame of delay that's being fed back into our system. And the more I turn up that opacity, the more we're going to see it, the more prevalent that feedback is going to become. So I can have this just simple taking that frame and delaying it and feeding it in at an opaque value. If I just put it to a full-on opacity, I'm just going to be stuck in one position. We're not going to see the movement there. So generally you want to keep things less than 100%, and that applies to if you ever work with feedback in audio too. But let's look now at something if I do a transform. So I'm going to take my transform, and if I had a scale of 1, which in Touch Designer in this case would be 100%, we'll see nothing happens. But if I set that to say 1.01, we can see that I start to shimmer a little bit. So the feedback is now moving sideways, as we looked at in that example. And if I have both scale parameters sort of to be similar, so if I have them both at the same value, it's going to move out. It's going to move out evenly, rather than if I say only do 1. So it's like our XY coordinates. The coordinate that is transforming is going to go up in this instance. And if I remove that and did the sideways, we have to the side. So we can see already this is kind of a neat effect. And if we started putting in some of our generative art into this system, we might get some quite cool things. We can also play around with introducing different parameters like edges and blur. So if I move this into my system, we'll see now that I have these white edges. And if I play around with some of those values, if I turn those down, we see that increases. And I could later on, I could go in and incorporate the color values for this. So I could do a multiplication and incorporate the color values from my face from the video feed and mix that with the edge. So rather than having this white movement, we'd have something that matches the colors that's coming into the camera. Rotation as well. Let's try a rotation. We can see this works similarly to that video feedback operation from earlier. Remember in those pictures that we saw, that when the camera rotated, we got like a rotation effect. So quite radical right now. Let's do a smaller value. So we can see that over time we're enlarging with that transform, but also rotating. And you could play around with just adding in different effects into this kind of system once you have it up and running. Like you could have things like a blur, like additional blurs. You could have sharpens. And as we move forward with the course, we're going to look at this idea of image matrices for things like creating sharpening algorithms and for creating things like blurs. It also allows us to get into this idea of thinking around machine learning, because quite often machine learning use these small matrices to check for certain pieces of key information in an image, and we can think about matrix math. So that's going to be kind of fun, and this provides us sort of like an entry into that. So we will in lab be looking at building something in Touch Designer, as well as building a feedback system in processing. We're not going to look at doing camera feedback in processing like this. We could add what we make into working with the camera, but we'll be looking at something that takes our generative art and starts feeding it back. So we'll be looking at Touch Designer and processing in lab. So we have a framework of 2 programs to look at and compare. Oh, the sun's come back out. Just moved a little bit to avoid the sun. But because this lecture's online today, I didn't want to add in additional video content, but I'm going to link to 3 artists who I think are important to look at in the context of video feedback. The first is Paloma Kopp, who does really amazing work with physical video feedback with old school analog video equipment, and sometimes physical things like prisms. So her work's really cool, so I'll link to that. Also someone called Andrew Benson, who does a lot of work with shaders and feeding back shaders. He does a lot of web stuff, as well as performance for like large musical artists in their stage shows. So I'll link to his work, and I'll also link to someone called Paul Prudence, who does a lot of stuff with natural system algorithms, emergence, but also feedback. So 3 artists that you should check out, and they're going to factor into the course. That we'll have a test about this, so make sure just to take a look at the links that I provide, okay? And I'll have a document linked in the e-class and on the GitHub that has all the links that are relevant to today's lecture. So it's a bit of a shorter one today, but we'll have another video on Friday, which is going to go through the process of using Touch Designer and using processing to create video feedback. So we're going to learn a whole new set of skills, which is going to be really fun, getting into this sort of image-based processing. And yeah, I'm excited. I really love feedback effects. So we'll create some quite interesting stuff. We're also going to get away from this just purely camera feedback and start feeding back noise. And through feeding back noise on itself, we can create these reaction diffusion type systems, which look really great, and kind of give us a bit of an in to thinking about some more sort of mathematically complex things through this sort of physical interaction with images and software and code. So it's going to be fun. See you all on Friday in video form.